says happy.
Hey guys, this is Appa with Appa Talks, and I just want to walk through a project build that I did to give my household just a little bit of extra power during those Texas emergencies. This last month has not been the greatest for our grid. We had a single rain 2 weeks ago that kind of put me over the top to do this, that caused us to have a 4-hour outage, and it was just a super light rain. So this is one of a kind, on a dolly, portable charge station. I want to go ahead and go through what I did so that anyone can do this. I am not a professional by any means, and I just want to talk about each of the components and what I'm doing for this device and how I will be using it for the future. So the heart, well, not the heart, the heart of this controller is probably the battery. The battery I got here, sorry about the lighting here. Let me see if I can fix that here. Yeah, the battery I got here is a Chin's 300 amp hour, 12 volt, deep cycle lithium phosphate battery. I saw a YouTuber, I think his name is Will, post a video about its cousin 200 amp hour battery. And he gave it a thumbs up, and he's also I want to say he's a professional hobbyist in solar. I'll post a link to his channel in the video I was looking at. Anyway, this is the battery I got. Most expensive part of the build, but also one of the more critical ones. And once I got the battery, I also went ahead and get the components. Now, my main goal was I wanted something that is both portable and powerful. And at first, I was looking at the commercial battery packs. Hobotech has a great review on Blue Eddy devices, and I was seriously putting some considerable thought into buying one of Blue Eddy's larger battery banks, because it would pretty much handle everything I want to throw at it. Except, I think I could do it better myself. Not better, but a little bit cheaper with more power available to me, if you understand what I mean. So with that in mind, I went ahead and searched Amazon for all kinds of things that I could possibly carry this on, this whole thing. And I was looking at things from carts to boxes, and then something just said, how about a dolly, since this battery is almost 80 pounds? And on Amazon, I found a whole bunch of dollies, and I eventually ended up on one that is a type of plastic material. That was one of the things. I didn't want it to be any kind of metal on metal, or at least not a lot of metal. So I got this pretty decent sized dolly. It can actually change into a cart, which I didn't really care about, but it has that ability. And it's a $70 dolly, so not that expensive, but not that cheap either. And for what my goals are, it's perfect. And I'll tell you why. Because I wanted to mount the brains and the bronze of the system in a vertical fashion. And so I got some wood that just happened to be perfectly sized for the frame of the dolly, that would allow me to bolt it in pretty well into this, into this frame. So this is solid. This is solid bolted in there. And that gave me a very nice platform to actually get everything on there. So let's go to the bronze of the system. That is going to be this Giandel pure sine inverter, pure sine wave inverter with a, well, I'm not using the solar controller, which would have been this part. They have another model that gives direct output for AC here instead of the solar controller. That's almost $100 different price difference. Nearly the same operation with everything else. So since I'm going to get the brains of the system as a charge controller, I might as well go with the cheaper one and not use this. And you guys understand. Anyway, it's a 2,200 watt, so this should allow me to run pretty much everything in the house if I needed, if it came down to it. You can see the specs right there. And right now I only have one panel, one 100-watt panel connected to it, just because I'm getting everything designed and put together. So I can, oops, let me turn that off. I don't need that anymore. Actually, that's not bad to have. I can connect a whole bunch more panels with that 20 amp input current. Oh no, actually, this is the inverter. Sorry, I'm thinking about this. So yeah, we can put up to 20 amps. And anyway, let's look how the battery is connected to the inverter, because this is important for safety and all that. I started off with 0.1 gauge connectors. I went ahead and created them myself for the connectors right here, and here, and here. I got a, what is that? A 200 amp circuit breaker. Now I was thinking of how do I actually mount this to the system, and eventually I was thinking I could run the wire all the way to the back and then all the way to the terminal. But ideally, you want to have these wires as close to the battery as possible. So I came up with a free-floating idea. Here, let me remove these cups. I'm just using those to cover the terminals for the time being. I came with this free-floating system so that it's actually just suspended in the air. It's not movable. It's pretty solid, and it works just fine. So, and these are cool to the touch. Well, I'm not pulling any load at the moment. But yeah, so I also have, you might be noticing some other cables connected to the battery. I got the MPPT controller connecting to the battery for charging. And I also have, these leads should be connected. These small little wire leads should be connected to the terminals, but I'm trying to keep them clean, and I don't see any issue with connecting them to the leads of the inverter. And that I'm using to monitor the actual current and voltage of the battery outside this area. So I can actually keep an eye on it when I'm not around. All right, let's move on. Well, actually, let's continue looking at the inverter. You got a couple nice fans. I did a lot of research. I don't know how to pronounce this. Giandel came out as one of the top brands to, you know, put your money into if you're going to do this right. Let's go to the front right here. Go ahead and turn it on. I'll turn it on with this little switch over here. Come to the inverter. We got our communications piece. That's connected to that little, no, I'm sorry, that's not a communication. That's the remote control connected to that. This will give us both voltage of the battery and how many watts we're pulling out when we have the device turned on. This is another solar charge controller, not the MPPT kind, just your basic run-of-the-mill integrated. You could use that, I suppose, if you wanted to. I have this connected to a power strip. My thinking is I don't need to constantly pull and unplug things from here. This is a 15 amp breaker, so no matter what I draw from here, it shouldn't be enough to actually tax this inverter, enough to like break it or anything. If I need something with more oomph, I do have this dedicated socket right here for all that good stuff. I have a earth wire. I went ahead and just created this myself. I have an earth wire that is just the earth, and I'm plugging it into a wall outlet to have it grounded. The two prongs, and you know how the US outlets are, they have the two prongs and then the earth at the bottom. The two prongs up here are not connected to any cabling. So it's literally just earth to earth. So it's a safety measure. I think I'm doing that right. I could be wrong, but it feels right to me. Let's look at the mounting. We can see I do have a good solid inch of, well, maybe close to an inch of space behind the inverter. That should allow enough breathability for if it does get hot. I also have it mounted using these little rubber garments that came with it. That should help prevent vibration. The garments go on both sides. Not too bad. You can see I have this big old belt. Just something I had laying around the house that it ended up being perfect for this use. To actually keep it tied well to the dolly. That way I don't have to go around worrying about it, you know, flopping around or anything like that, especially if I make it mobile or moving it around. All right, so that's the bronze of the system. It's a pretty decent size inverter. We'll power this up here in a second. Now let's go to the brains of the system, and that is going to be the MPPT charge controller. Another what do I say? What do I want to say? Another piece of equipment that was very important to pick the right one. So I did a lot of research on various ones, and this one just seemed to coming out on top, or at least in my research. Okay, let me turn off the light so don't got too much of that. All right. So let's see if I can get that to. There we go. So this model is a tracer. Let me read that for y'all. I can't even read that without the camera. 4215BN. Serial number doesn't matter. All right, so here's the important parts. Max solar cell input to 150 volts with amps, 50 amps. So that's awesome. I can put a whole bunch of these in parallel and get what I need. A whole bunch of solar panels in parallel. In any case, let's see, what's something I care about? Here we go. Rated charge current is 40 amps. The output, 20 amps at 12 volts. Now, something important about all of these is you need to make sure you do have breakers sized for your wires accordingly. And I choose the wires for what the output of this stuff is. We'll go to the wiring next after all this. Now anyway, the MPPT controller has several functions. You got your solar input right here. That's connected. Let me turn the light back on. Sorry about that. That's connected to the solar panels. Got your battery to the battery. And then this is your load, which I have connected up to one of these things. And this will give me, here, let me turn that on. Let's start putting full load on this. Or not full load, yeah. I must have turned it off. This thing is a little bit slow to the delay. Yeah, you see how fast that was? So this thing has both a 12-volt battery, or I'm sorry, cigarette lighter, a couple of USB ports, and a little monitor. I'll be using this a lot to charge my battery, my other portable battery banks. So that should be pretty cool. Turn that off. Turn that off. So I'm not using that. See that delay? All right. And let's see. This is a communication device, or this is the communication for this. And this right here is a temperature probe. I didn't really have any place to put it, so I put the temperature probe right under the belt at the far end of the battery. You can see it right there, that little metal piece. I don't know how useful that's going to be, but it's there. Okay. You got a couple blinking lights. Let me turn this off. Indicating there's charge coming in through the solar panels. This is to the battery. This right here, I have no idea what this button is. It's lit up a few times, but in the manual, it just says it's a button. It doesn't say what it does. So that's interesting. And then I'm not going to push it without knowing what it does, but I haven't needed to push it. All right, and then let's go up a little bit more to the accessories of the environment. So here's our controller. This is user definable, so that I'm able to tell it that I do have a 300 amp battery. In fact, let me go through the various things. And then here we probably don't need the light. Sorry about the light on and off. So I got the date, time. This is telling me, I think this is telling me how much energy I'm getting through the solar panels. This is our battery currently. Our maybe this is through our solar panels. This is telling us the metrics of our solar panels, I'm assuming. 62 watts, so that's what I'm pulling in right now. Not too bad. And that's with one 100-watt panel at 4 amps. So I'm going to double up that amperage within a couple of days. That's the temperature. Currently no load going through that. And so I have that on manual control, and there you go. So yeah, and then you can user define it. So there's all these other things. So let's say, oops, let's go back. Yeah, you can go to the control parameters. And this is where you'll define everything. So I'm able to tell it that I have a 300 amp battery. Chins sent me information on how we should control charge controller. So I got all these defined. Took me a while to figure out how to do this. You have to actually go through it and set other values. Otherwise, if you have conflicting values, it'll give you an error without telling you why. So anyway, you got all that good stuff. Let's just go back to monitoring, which is the best. And then our little on-off button for the inverter. Oh, and then this is a quick disconnect to the solar panels themselves, so that I don't have to actually have it wired in the entire time if I don't want to, or if I want to move it around. Now let's go to the wiring aspect. That's one of the more daunting aspects. Because if you're not careful, if you don't know what you're doing, that is actually putting out a lot of energy. And that could potentially be fatal. Just a heads up, that potentially could be fatal. So, mind you, I am not a professional. And if I'm doing a mistake, call me out. Let me know. All right, now let's go back to the back. Oh, I have this plugged in there because we're actually powering the TV as our test load case, and it did last an entire day. So I'm happy with the battery's capacity. All right, we'll start from the bottom since that's what we're looking at. It looks like we have, what's that? So these are the cables going to the solar panels. Got that connected to a 40 amp breaker. Those are pretty cool. These then go into some pre-drilled holes that I created. You'll notice I put a little bit of shrink tube around to help protect the cabling. I kind of forgot to do it here, but this isn't moving anyway. So yeah, that's something you can call me out on. And then I have the communication pieces going through this other hole up here. And just circling around back, you'll see, to keep it all nice and clean, that's how I'm doing it. That way I don't got wires all flopping around. I then have them, and then if we go around, we'll see I have tons of zip ties. Trying to do good cable management is my goal. This next 40 amp breaker is, what is that? Oh yeah, that's the, I don't have a 20 amp in there? Oh, I do have a 20 amp. Okay, so this is, what is this one? Oh, this is from the solar panels going into the charge controller. This is the charge controller going out to the battery. That's what I'm looking at. All right, so just good old cable management where I think I can do it. I do have kids in the house, so they are aware not to play with this thing. Right, June? Yeah, I'm over here. And then just trying to keep everything tidy. Another thing I like about this Dolly, because it's plastic, it's easy to drill through. And so I got little holes just to move the cabling through. Now this is a 20 amp breaker because this, I don't need it to pull more than 20 amps, and the MPPT charge controller can only push 20 amp loads through it. So that's why I've made a 20 amp breaker on there. Oh, and the black tape, that's to like hide some of my bad woodmanship when I was creating the holes to mount these through. So yeah, like I said, I'm not a professional in any means. But it does a good job. And then you can see that from the solar panel connector. And that is pretty much the entire system. Let's power it up and see what we can do. We'll be back here in a second. All right, so we're going to do a double load test here. Let me just plug this in real quick. Is that the right way? Yeah. Sorry. Oh, I need to hold it. Oh, there we go. All right, we're going to do a double charge system here. We're going to try using a, what is that, a toaster? We're going to use a toaster.
Yep, that's right.
That's right? All right. So we're going to use a toaster. Oops, let me turn on the light here. And we're going to use a vacuum machine to see if this thing can handle the load. So we'll start off by first giving power to the inverter. Looks like that button's a little bit finicky. All right. And see the inverter came on. So let's start by turning on the toaster, which is plugged into the main outlet, because I know this draws a lot of wattage. So we can hear it turning on. Turn this off. Pulling, what is that? It should tell us 700 watts. Wow. All right. It is getting red. Let's see if the battery's changed in voltage. It was at 13 and it's dropped down to 12.7. I do need to charge the battery. It's only been charging for a while, so that could be part of it. But in any case, it's charging. Let's see if we can turn on the vacuum machine. Still got that red. There we go. It's working. I don't understand those numbers. Oh, this has kilowatts and output. Interesting. We'll just give it a full load until the toaster finishes. See what this tells us. Uh-oh. Looks like something tripped. Oh, it was my 200 watt thing. Well, that was a good test, wasn't it? All right, let's reset it. Oh, actually, yeah, let's reset it. Oh, it can't reset. It's too hot. Interesting. But the terminals are cold to a touch. So I've just ran into my first issue. Hey guys, so I'm just doing a little bit of bathroom calculation here so I can determine why the amperage breaker tripped. As y'all recall, I have a 200 amp breaker in the back for the battery. The sine wave inverter is rated for 2,200 watts. So if we divide that by 10, we can theoretically pull a maximum amperage of 250 amps from the inverter. That explains why the thing tripped, because I only have a 200 amp breaker, which means I can pull 2,000 watts. I remember why I did that, so I don't accidentally take too much from the 2,200 watts that this thing is rated for. Give myself some breathing room for allowing it to not break itself. That's something I'm going to have to test for. So the wattage pulled from the inverter was too much that it tripped the 200 amp. Well, that's what I wanted it to do, so that must be just slightly more than what I can handle, which is interesting. All right, we'll let this cool off and we'll reset it. There we go. Let's go ahead and turn this back on. And you know what? It looks like it tripped. Oops. It looks like it tripped when this finished. So it must have gone over slightly. Why don't you guys tell me down in the comments. However, I am happy that it can at least pull all that for a little while. Let's just give it another test, but using just a vacuum machine. All right, so future plans for this is I'm going to want to keep this around for keeping heater, probably fans, lights, keeping our laptops charged, all that good stuff, especially during the outages or when we're working. So I hope this has been informative, entertaining, and if you guys have ideas or suggestions, just let me know. This is Appa with Appa Talks. Did a couple of little other extra ones before I arrived at this number. So, yeah, math is important, kids. Everyone learn your math. And this actually works out. This allows me to know if I'm drawing just a little bit too much power than I want to. Anyway, June, you want to say bye for Appa Talks channel?